Yo, what's up everybody? This is Cameron Snow at Danomics. So in this video, I'm going to show you how in just a couple of minutes with just a handful of button clicks, you can determine the landing zone for all the horizontal wells across an area. So let's get started. So in Danomics, you can come in and generate structure maps, based on the top picks from your cross sections that you've done. It's a really simple process. All you have to do is come to our structure gridding flow here, where you're going to grab your tops, you're going to use the deviation surveys to put everything in TVD space, and then in one go, we're going to make all of the structure grids for our project. We hit the run button. This area just takes about a minute to run for 5,000 wells, covers a couple of counties in the Midland Basin. All right, so at that point, we then have our structure maps, and these will be, you'll be able to view these in 3D here. So I'm going to turn off my horizontals so you can see these precisely here. Now, I actually have a lot more grids than that in this file, but I'm just showing you a select few just for demonstration purposes here. Now, the question is, how can you go in then and identify the landing zone? So we have built some new tools. So I have this new zone lookup tool. What you do is you bring in your deviation surveys. You then use that structure grid that you're working on. Tell it what horizons you want to use. We then have our new calculate landing zone tool pending release here in August 2025. And then I'm going to write out that to some points. I want to map it up, so I'm going to add my well headers to it. And in this case, I want to look at the Wolfcamp B, so I'm going to filter it down to just that formation. And run this. Once again, it runs across 5,000 wells for multiple zones in just about a minute. And when we look at the output here, I'll zoom in a little bit. What it gives us back, it tells us, yes, this well meets our criteria for a horizontal. Yep, here's the landing zone, here's the percent in zone, here's the feet in zone, and then we've got the coordinates that we can use to map that up. Now, once we've done that here, and I'm going to zoom back out a little bit, now we can do a couple of things with that. First of all, we can, QC these wells and come over here to our 3D view, and we can say, all right, are these wells landing in this zone as expected? Yes, they are. So remember, these are the ones we filtered to just the Wolfcamp B. We can also see that in a few cases, we have some of these wells that are popping through. So they landed really kind of on the boundary of Wolfcamp B and Wolfcamp C here. It's still classified as Wolfcamp B based on where most of the lateral is at. Now, let's say we want to view that in map view as well. What we can do is come here to our map, and I'm actually displaying some of the wells here. And I'm displaying a subset of the wells based on the points that the wells that we identified as landing in the Wolfcamp B. So I'm only showing the 1,600 or so wells that landed in the Wolfcamp B here. But we can also add a bubble map here, and this bubble map, I really like this. What we're showing here is we are looking at the feet in zone as the size of the bubble here, and we're mapping that at the bottom hole location of the well. So here, we can see that, hey, we had some relatively short laterals, kind of low, low number of feet in the zone. Here we can actually see a really cool progression of going from less feet in zone to more. It looks like one of these wells in here, this well that was drilled up to the north, a very small amount in zone considering it's a 10,000 foot lateral. And if we want to annotate this, we can turn on annotations as well. We do this using a point scatter plot, which allows us to add labels to this for feet and zone. And this allows us to come in and say, all right, even though these laterals all look nearly identical to us, which ones have more in zone, less in zone, etc. And we can see that even amongst this small handful of wells, we're seeing a 2,000 foot difference in effective lateral length, and that could go a long ways towards explaining production differences across the area. All right, if you think this is really cool and you want to give it a try for yourself, just hit us up at sales@danomics.com and we can get you set up with a trial to test this out. If you're already a customer and you want to learn more, just shoot us a note at support@danomics.com and we'll be happy to help.